Hello everyone. In this video, let's take a look at the product rule and specifically how the product rule can be applied to square roots. So the first thing, let's take a look at what the product rule says. It says if a and b are non-negative, then the square root of a times the square root of b is equal to the square root of a times b. So when we're multiplying two square roots together, we can combine them and put both of the numbers underneath that square root sign. This is going to make it a lot easier for us to do things like simplifying radicals, or it gives us a method that where we can multiply two radicals together to find a solution. One thing to note right away is that because we have an equal sign, this does work both ways. So for example, I can go in this direction. So if I have two separate radicals, if I have the square root of a times the square root of b, I can combine those together into a single radical and have the square root of a times b. But because of the symmetry of an equal sign, we can go the other direction as well. So if I have the square root of two numbers multiplied together, so if I start with the square root of a times b, I can use the product rule to separate those into the square root of a times the square root of b. Okay, so that's very useful. So one thing I'd like to do right away is just take a second to explain, using a specific example, why this works. So let's use something that we already know, something we're familiar with. So let's think about the square root of 36. Now, hopefully, we're familiar with this, and we know that the square root of 36 is equal to 6. We know that this is true because 6 times 6 gives me the 36. Now, what if I were to rewrite this a little bit? So instead of saying 36, let's rewrite that as 9 times 4. All right, so the only thing I changed here, it's still a square root, but instead of writing it as 36, I'm writing it as 9 times 4. Well, 9 times 4, that's equal to 36, and if I take the square root of that, I still end up with 6. Now let's change this a little bit more. We're going one step at a time here. So instead of the square root of 9 times 4, let's say the square root of 9 times the square root of 4. Okay, so the only thing we changed here is we separated the two square roots. These are both perfect squares, so we know that the square root of 9, that's the same as 3, and the square root of 4, that's the same as 2, and then now we can multiply these together, 3 times 2, we do end up with 6. So when we compare what we started with, the square root of 36, and then we did the square root of 9 times 4, and we know that's still 6, we can separate that, and we can see we do end up with the same answer. So it is important to note that the product rule only works with multiplication. This does not work with something like addition. So for example, if I have the square root of 9 plus 4, this is not the same as the square root of 9 plus the square root of 4. And we can see that if we just think about what these numbers are. 9 plus 4, this is the same as the square root of 13. And then on the other side of the equal sign, square root of 9 is 3. Square root of 4 is 2. We end up with 5. The square root of 13, this is going to work out to be just about 3.6. And these two numbers are not the same. So this does not work with something like addition. It has to be multiplication in between. Okay, so now that we understand the product rule, let's use this in a couple examples. So one of the main things we use the product rule for is to simplify radicals, so simplifying square roots. So I have a couple here. The first one is the square root of 75. Now the main thing we want to do when we're simplifying radicals is we want to take the number underneath the square root sign and we want to separate it into two numbers multiplied together. And the numbers that we want to choose, we want to make sure that one of them is a perfect square. So the question I always ask myself is, what is the biggest perfect square that this number can be divided by? So if we just need a reminder of our perfect squares, our perfect squares, we have 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, so on and so forth. Now let's take a look at 75. So first thing I want to do is take 75, split that up into a perfect square times some other number. So which one of these can 75 be divided by? Well, it can be divided by 25. So this is the same as the square root of 25 times 3. And now that it's written like multiplication, we can use our product rule to separate this. So separating this into two separate square roots, we have the square root of 25 times the square root of 3. And now we should be able to simplify. So we picked out 25 on purpose because we know it's a perfect square. So the square root of 25 is 5. 3 is a prime number. It's not a perfect square, so there's nothing we can do with that. So our simplified answer is 5 times the square root of 3. Okay, let's try the second one. So the square root of 80. So same idea. We want to take a look at 80, and we want to ask ourselves, what is the biggest perfect square that goes into this? If I do the biggest perfect square, it's going to save me some steps. In this case, 80, the biggest perfect square that goes into this is 16. So this is the same as 16 times 5. And again, now that it's written in multiplication, we can separate this using the product rule. So the square root of 16 times the square root of 5. And to finish simplifying, the square root of 16 is 4, and the square root of 5 has to stay as is. All right, let's take a look at one other example. The other main thing we use the product rule for is multiplying square roots together. So when I have two different square roots, I can multiply them together, make it a little bit easier to work with, and then we can finish by simplifying if we need to. So in the example, the square root of 6 times the square root of 12. The square root of 6, that's not a perfect square, so we can't simplify that. The square root of 12, okay, that one doesn't work out to a whole number either. But we can use our product rule to multiply these together. So bringing them back together, this is the same as the square root of 6 times 12. And now, since they're both underneath the square root sign, we can multiply them together, and we get 72. And now this is something we can work with. So just like we did on the last example, let's simplify this. So what is the biggest perfect square that goes into 72? That's going to be 36. So 72 is the same as 36 times 2. And our product rule, we can separate this into the square root of 36 times the square root of 2. And then to finish up, the square root of 36, that simplifies to 6. And the square root of 2, this is just going to stay the same. So those are the two main uses for the product rule. We can simplify radicals with it, or we can multiply two square roots together. Thanks.